Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Are you working with a monorepo? Then it's probably a good idea to use Melos, a CLI tool that helps you manage your packages. Lukas Klingsbo is a Google developer expert in Flutter and Dart. He's the maintainer of Melos and part of developing popular packages such as Flame and Audioplayers. Let's go!
Hello everybody. I am Lukas, or Spydon online, and I'm part of the Bluefire open source collective, and we're making packages like the Flame game engine and audio players and lots of other packages, so you might have seen our packages around. And I'm also an organizer of the Flutter and Friends conference in Stockholm, which takes place this autumn, so check that out. But that's not why we're here today. We're here today to talk about a tool called Melos, and why, when and how you should use monorepositories. And the agenda for today is that first we'll go through a bit what the problem is, or what is the problem we're trying to solve with this tool. And then we're going to go through two concepts called conventional commits and semantic versioning, which Melos is using to function. And then we're going to go through a bit more what Melos is and what it does. And then we'll end up with a little demo so you can see it in action. So let's get started. So what is the problem, first and foremost? So imagine that you are a consultancy, for example, and you're doing like white labeling apps. So you're creating lots of apps for different customers, but you want to share widgets and like probably some logic code, maybe some API packages between these different apps. And it can be quite a struggle to have all these packages in different repositories, because then you have to have path dependencies outside of your current project. And if they are published, then you have to publish them all the time when you're making changes. And if they're not published, then you have to rely on the path dependencies. So by putting all of your packages inside of a monorepository, you can do atomic changes so you can do changes within a package and within an app within the same commit, which can be quite nice. And also they are always connected to each other, so you don't have to publish to use the latest version that you've just made changes of in the packages you're depending on. And we had this problem a lot in Flame. We have probably 25-30 packages or so in Flame, so you can imagine it was quite a struggle before when we had to publish to get a new version here and there, and then it was then also you're not sure that everything that is in the repository is up to date with the latest version. So, and then we're going to talk about these two things called conventional commits and semantic versioning. So we'll start off with conventional commits. So conventional commits is a concept where instead of just writing the description of your commit messages in Git, you're also adding a type to them. And these conventional commit types, you can use, you can make up your own types if you want to, but I recommend using at least a subset of the ones that are defined on conventionalcommits.org. And some simple ones could be feat, for example, which is short for feature, or fix, which is short for bug fix, or if you want something that is not related to versioning, etc., we're going to talk about later, you can use things like sure, or there are also things like refactor, and there are lots of different types. So instead of just writing your description in the commit message, you first write the type, like you can see here. These are some examples. So it will be, this is a new feature, so we say feat, and then we have position component now has built-in decorator. So this is what you would have had as your just normal commit message before. And if you're doing a bug fix, for example, then you just add fix in the beginning. And if your commit contains a breaking change, then you should add an exclamation mark like this in the end, so that any system that is using these conventional commits will know that, okay, here we need to bump major, which we will talk about later. And then we also have an optional scope that you can use, and that's just parentheses after the type. And here you can have maybe you're working on a bigger feature that will contain many commits or pull requests. Then you can write something here that groups them together. Or maybe if you're using like Jira or a tool like that, you could have the ticket number in here. So that's all about conventional commits. Now we're going to talk a little bit about semver, or semantic versioning, which I guess most of you have seen in some form before. And semantic versioning contains of 3 numbers: major, minor, and patch. And this is in the simplest version of semantic versioning. There are other things that you can add in the end too, but we will not talk about those today. So the first number, so we have an example here, 1.1.2. And if your app, or if you're change, like when you're releasing a new version, if since your last version you've done breaking changes, you have to bump major. And that is the number, the leftmost number. So then if you have done that, this example would, for example, be 2.0.0 after you have done your new release. And if you have just released new features without any breaking changes, you're bumping the middle number. So it would become 1.2.0 in this case. Or if you've just done a lot of bug fixes, then you're bumping the last number. So it would be 1.1.3. And say that you have done like 10 new features and 15 bug fixes since the last version. Then you don't have to, you only bump it with like the biggest number to the left that you can find. So if you have done that many changes, it would still only be 1.2.0 would be the next version. So you wouldn't bump it once for each change you've done, if you're not doing a version after each change. But that is usually quite uncommon. So how does Melos help with this? So Melos has automatic versioning. So when you're releasing a new package, it will just look at all of the commits that have gone in, and then it can calculate which packages should be released here and which haven't had any changes, and what are there new versions that should be released. So then Melos automatically updates all of your pubspec files and just publishes them to pubdev. And another really handy thing is that it does changelog generation. So you never have to change the changelog meanwhile you're developing. Like you can do lots of pull requests, but the changelog only changes when you're doing a new release. So this, if you have a big team, for example, and you have had so that you have to change the changelog after each pull request, then you know that it's very common to have merge conflicts in there, which can be quite tedious. So Melos just removes that problem altogether, and it creates really nice changelogs, which I will show you soon. And as I said, it will publish all updated packages and leave the ones that are not updated, so you don't have to figure that out yourself. And probably the most used feature, or the most kind of why Melos was built from the beginning, is to link all your packages together in your monorepository. So if you're depending on all the packages in there, and you can keep on depending on them with their normal versions instead of having path dependencies. When you're publishing a package, you can't have path dependencies in it. So if you don't have this local package linking, then you would have to swap back and forth between path dependencies and the ones that are released, which is really tedious too. So Melos is using something called pubspec overrides to do this. And another feature is that you can share dependency versions. So in the Melos YAML file, you can just say that I'm using freezed in all of my packages, and I want all the packages to have the same version inside of their pubspec files. Then I can just define that version inside of the Melos file. And then when I run Melos Bootstrap, like I will show you later, it will update all of the versions of the packages in there and apps. And it also has this feature that you can run scripts across all packages, or you can define filters so that it runs, for example, if run these scripts for all packages that have the test directory, or run all the scripts for the packages that depend on some code generation library. So that is also really handy, especially in the pipeline. All right, let's get on with a bit of a demo then. All right, so I have created this little monorepository here, which I have called conferences. So it should be maybe a monorepository for different conference apps. And as you can see in here, there are two directories called apps and packages. And then in the root, we just have the melos.yaml file and the pubspec.yaml file. So let's go in here. And so as you can see, we just have two different apps here in the apps directory, Flutter and Friends and full Stack Flutter. And they're just like normal apps. And then we have two packages called Conference API Client and Conference Widgets, which both of these will use later so they can share some code. And also you could publish them so other people could use that code too without getting your whole app or something. Let's start first to have a look at the root pubspec file. So the only thing that you should define in here is the version of Melos that you want to use. Because this makes it possible for you to have lots of different monorepositories with Melos locally, but that are using different versions. Because you can have any version of Melos installed as the binary, and then it will look in here and use the version that you have defined, or use a version within the range that you have defined. And yeah, you should not declare any other dependencies in here. And the name up here, that doesn't really matter. It's just the name for the workspace pretty much. And here, this is the normal Dart SDK version that you want to use within the repository. Then we can have a look at the melos.yaml file. So this one is the simplest melos.yaml file you can possibly have. It's just the name of the workspace here too. And then you define where Melos should find the packages. So here it will look inside of the apps directory and all its subdirectories, and inside of the packages directory and all its subdirectories. And in here you can also later define things like scripts, and then define different scripts that should run on all of your packages and apps. And you can also define these common dependencies I was talking about earlier, but we won't have time to talk about those today. But there are some great documentation about those on the melos.invertase.dev. You'll find that easily by Googling. So let's get started by just adding this conference widgets package to one of our apps. So let's go in and add that to the Flutter and Friends app. So I believe it was just called conference widgets, and we want the version that is bigger than 1.0.0, right? And now if we run flutter pubget in here, you can maybe guess what will happen. It will fail because, yeah, conference widgets isn't a package that is published to pubdev. So pubget cannot find it. So therefore, version solving failed, like it said. And that's when we use package linking. So then we run Melos bootstrap, and this runs pubget in all of your packages, and it also locally connects all of the packages and apps that are dependent on each other with these pubspec overrides that I was talking about earlier. So now all of a sudden I can run pubget, and then you can see in here that conference widgets 1.0.0 from path blah blah has been overridden in pubspec overrides. But after running Melos bootstrap, you don't have to run pubget since Melos bootstrap already runs that for you. But I just wanted to show you here how it looks like and that it works. So say that we want to do a change to this package that we called, or first actually we can say that we have added this dependency here, and so we'll just do add pubspec.yaml, and since it has also added some lock files for the other files which weren't there before when we ran Melos bootstrap. So yeah, we can go ahead and add those two, doesn't matter. So yes, so that we will have a clean git state. And since we can say that this was probably, we can say that this was a new feature. Or actually, we can say that it was a shore. A shore is something that doesn't affect anything else. So then let's commit this. And then we do this conventional commit tag called shore. And we can say we added the, what would we call conference widgets dependency. And now we can just push that. Oh, and now I have probably done something dirty there. Let's just force push it. And now let's go on and make a change to the package I was talking about. And all the packages are inside of packages here. So let's go into the conference widgets. And we want to make a change to the Dart code here. And as you can see, this isn't actually a package, it's just an app. It's just one of the default Hello World apps, but it doesn't matter because we're not going to use any of the code there. So let's change Hello World to Hello Flutter and Friends, and then save it. And then let's say that this was actually, this was a bug fix. It wasn't supposed to say Hello World there from the beginning. So then we can add this. And a bug fix has the conventional commit tag fix. So we add that there and say show correct message to user or something like that. Yeah, make sure to write descriptive Git messages. No, not like this one. And now we have done our change. And can push that too. And then we want to create a new version. So then we can run Melos version. And now we will see that, oh, no packages were found that required versioning. And that is because none of these packages are actually on pubdev, because I didn't want to pollute pubdev with lots of garbage packages. So, but down here it gives you a hint, says that you can run it with all to include private packages. So that's what I'm going to do. And then you can see that we have two new versions here. The conference widgets has been updated to 1.0.1 with patch changes, which are bug fixes. And you can see here that the Flutter and Friends app has been updated because it got a new dependency. So then we can just press continue, and versioning was successful. And then we can have a look at the root here again. Then we can see that the changelog.md file is created. So the root changelog MD file, it contains all the changes of all packages in the repository. So most of like if you want an overview, you can look in here. But most of the time, and what will be shown on pubdev if you're publishing your packages there, is the changelog that is within each of your package. So here you can see that it has the changelog for that. And after you have done the versioning, you obviously want to publish your packages. So you can just run Melos publish. And now it says, oh, no unpublished packages found. And that is because our packages are private, so they don't have anywhere to publish them. But if you would have them on pubdev, then it would publish them now. And first, when you run Melos publish, it runs it with a dry run. So it checks that everything is all right with the packages so that you won't lose any points or something like that. But if you want to actually publish them, you run Melos publish with no dry run. And soon, hopefully, we will be able to do publishing and versioning directly from the pipeline in Git. So there is an issue open, 7177, where I'm trying to create this feature. We only need to like flip a boolean and add 2 checkboxes to pubdev, and then you will be able to just press a button inside of GitHub, and bam, all of your packages will be published and versioned, and you have great changelogs for them all. So if you think that would be a great feature, go into that issue and give it a thumbs up, please. I think it will simplify maintainers' lives a lot. And I think that is all we have time for today. I hope you enjoy all of the other great talks at Flutter Full Stack, and hopefully I'll see you all at some other conference. Cheers!